ask a question. Like, who knew before hearing of the talk what Loveholidays was? Okay, so competitors basically, I think, right? Like, how have you heard of it? Have you booked with Loveholidays? No.
Never booked with it, but I saw it listed on Google.
Ah, okay.
So I'm aware of it.
Cool. Yeah, thank you very much. Yeah, so some people, we had some user surveys. Some people think it's couple holidays or something a bit more shady, but yeah, it's yeah, I hear a lot of jokes every time I mention it. But yeah, it's really just an online travel agent, and we're trying to really grow quickly. Oh, I have to press here, right? Which the first one, I guess. Oh, which one? Yeah. Do I press here? On the okay, of course, yeah. Yeah. So about me, so I'm head of data science at Loveholidays. I try to make it short, but so yeah, I have some experience with quantitative research combined in academia and industry. So my background is computational cognitive neuroscience, and yeah, since coming to the industry, I've worked with transaction systems in financial services, and yeah, with neural networks on text documents, multi-GPU, multi-core, and then yeah, so also yeah, interested in talking or bringing it to the public. So then Data Science Speakers Club London was one of the founders, and yeah, authored 2 books on machine learning. And yeah, we also have open positions. Even if you're not interested in A/B testing, might seem a dry topic, but it's actually hopefully I can convince you that it's interesting enough. There's we work on a lot of different projects, so text, images, yeah, customer data, and yeah, and traffic acquisition, lots of different things. Yeah, so talk to me later, or to Yufan, who's also here. And actually, she's working on the A/B testing, like a lot of it. Yeah, so yeah, why do we experiment? So I've given it away a little bit. We want to yeah, really grow. So that's one of the main goals of the company, to grow quickly. And yeah, we were the fastest growing company in the UK in 2019, and coming back from COVID, that really affected us a lot, but we've managed to get through it. We are again one of the fastest growing online travel agents in the UK, and of course keeping on growing is kind of the main yeah, part of the company strategy, really. So after these 3 kind of parts of our motto, which is unlimited choice, which is about supply, and then unmatched ease, how quickly can people find their holiday, how they can explore on the site, and so on. So we work on a lot of that as well in data science. And then unmissable value, which is about the price-value proposition. So also a lot of tests about pricing and so on. So all of that is really about yeah, trying stuff out and then knowing if it's working or not. And yeah, so one added complication to our case is that people take a long time to make the decision, and there are a lot of different decision points in there. So yeah, we kind of from user research, it's kind of thought like this. There's first a dreaming stage where people, they look at some beaches and then think about it a little bit, right? And then they plan it, and then in the end they book it, and there's post-booking phase as well. So it takes a long time sometimes. After 90 days, 99% of people will have made a decision, but yeah, it takes weeks and not days. And this is also a problem in A/B testing, that experiments can take quite long. They have to run for a long time. So it's called a delayed measurement, and something that we are trying to tackle as well, then by applying certain kinds of models. Some of it is in progress, so I can't really talk about it yet, but other things I can talk about, which is the bias problem, which I'll come to later as well. Yeah, so more about the technical side. So we want to build an experience for people, that a website that works, that can like play around with and dream, and then yeah, make them happy, and yeah, they're engaged, and there's a repeat rate and so on. So even yeah, so different metrics perhaps there, and then yeah, also then the back-end side, or the website itself, we want to improve. Yeah, so and that's, yeah, again, so that's experimentation. And then, so what's an experiment really? So we have a random split, hopefully, if there's no bias, between people, usually cookie-based, that people get assigned to one or the other side of an experiment. Can be many sides, of course. and then you observe the behavior, and then you usually you look at do people book or do they not book? So it's conversion rates on one side versus the other side, and then you can calculate an uplift in between the two sides. And the good side about this is that it helps you to validate your hypotheses if what you're proposing is actually working, and it's objective. So you're measuring stuff, and it's not dependent on like the highest paid person's opinion, the hippos, but it's based on the impact of your change to customer behavior. And if your test doesn't work, you can redesign it. You can think about the problem again. Maybe you misunderstood the problem. Maybe you solved something that doesn't need solving. Maybe your hypothesis was wrong, and so on. So it's really a very interesting, really tool, I guess, right? And useful. So you can think about this here. I'm still not sure how this is working. Okay, right. So here you can think about this flywheel here also as a vertical. So we have our platform in the bottom there that we are trying to improve. Actually, we have one of the fastest search platforms in the industry. And then we have, of course, the website and the interface, how it's built up and so on, which is also our platform. Our website is very fast, one of the fastest again. And then, and then the design system of how you show things to people, how you can build up then these different parts of the website. And then, of course, there's user research where you come up with, try to understand the people better, and you try to come up with new experiments again. So this kind of the faster this kind of thing, faster this again, this thing spins here, the more you can create impact and have this build up more and more momentum then for your growth, basically. And usually what you aim for is the conversion rate or margin or something else. And then then what you really want to work on is then how many experiments you run in parallel. So that's the whole program then, experimentation program, and how many of these tests win, or what's the win rate of the experiments that you run. And that's then about visibility, creating confidence in the business and trust. And then finally, the last point is about how quickly you can actually use what you learn in these experiments, or how quickly you learn from the experiment. So that's about statistics and getting early insights from the experiments, and also about split changes and which again comes in with statistical intricacies. So you start with an objective, which could be you want to drive growth, which is bookings, and then then you come up with some hypothesis, and then in the end you measure then conversion or something like that, right? So it's just an example I found. So our implementation. So I can't really claim to have any part in this. Really, this is the data. What's it called? The DPI, the product infrastructure team, and they wrote a Rust tool that we can compile to TypeScript or call from TypeScript, and then it's extremely fast, 5 times faster than previously, or even more, and we can assign to experiments or bucket people into experiments. At the scale of 800 microseconds, basically. So extremely fast compared to before, and of course, very very important for us not to lose momentum because we are experimenting. This is about the statistics engine. So basically we have to load in our data, the ETL, so data extraction. And from, in our case, GCP, we are loading from BigQuery. Then we do the analysis and modeling, and different kinds of machine learning or statistical models. And then we visualize in Jupyter Notebook or on some other tools, and then we upload back to the database, and this then visualized for everybody to see then in the company. So if anything is wrong in the experiment, it's always visible to everybody. We have an automated analysis framework, which I call this statistics engine, and we have different kinds of tests in there. So the frequentist tests, we have implementation of Bayesian tests as well, which we're not really using much, but we have Bootstrap, and then as a kind of spin-off of that, we have the probability of winning, and then we have to control for bias. We also have an implementation for inverse propensity weighting in the sampling. So these are the things I'm going to talk about now. So the analysis methods. So how many people actually here? Maybe to get another read. How many people here have a data science background? Okay, cool. So a lot of this is probably boring then, but and it's the afternoon. So I was I mean, everybody knows. So it's very schematic. In statistics, you have a null hypothesis. You try to disprove it, and then the p-value tells you then if you can reject it or not, given your threshold. So that's basically it. If you're looking for the interview answer here to chance of observing a value more extreme than t. So that's the answer you should be giving if anybody asks you what the p-value is. So we have that implemented, and then but that's kind of the very boring stuff. Then of course Bootstrap sampling to get a bit more of a confidence interval of your statistics. So it's a bit more powerful. It takes a bit longer, but it can be parallelized, of course. So we would draw with replacement from the users basically that are in the different buckets. So we have always test variant against control variant. We draw and then we compare. And we basically compute the test statistics then n times. Basically just doing random draws at full size with replacement. And that's the Bootstrap, and this gives us then a bit more information. So we have a confidence interval, and we have a Bootstrap mean as well. So so that's the Bootstrap sampling, and then So and then this also gives us something else, which is then the probability of winning. So at say like 50% or something, what is the value, or at the 5 worst percentiles, what's the value, and so on. So this gives us a better idea of the risk of deploying an experiment. And then, we have some bias in the system sometimes, which has to do with latencies of JavaScript loading on different mobile platforms or desktops and so on, browser implementations and so on. And so that's the problem that we're trying to tackle as well with different methods. So I'll come to that in a moment. But so this is one of the problems, and then the one I mentioned before is the late measurement problem, that people really book after many days rather than just same day or very few days. So so the bias is can be tackled in different ways. One is the inverse propensity weighting, which is well-known method. So we would basically normalize the outcome for each user by how biased the assignment was for the user. So we have the propensity, which is a machine learned. Usually we use something like logistic regression or something. That's at least in the literature, to predict how likely somebody is to be drawn in the experiment. So that's the propensity. And then using the propensity, we can then weight how important this user's outcome is to the end. And then there's normalization here in the bottom, which is basically it's a curve like this here, so a bell curve, which means that the extreme confidence is weighted much more. So if it's 50%, it's normalized more. If it's at the edges, so kind of 0.1, 0.9, it's down. It's normalized much less. That's normalization here in the bottom. So it has a few shortcomings, which means that it has to be used with caution, but it's quite interesting to know. And what we actually implemented is something inspired by that, but not exactly that, which is the inverse propensity bootstrap sampling, which is basically using the propensity which is as an inverse weight for the bootstrap sampling. And yes, we've implemented that. We're still analyzing a bit, but that's what we want to use then in the future. And then yeah, so we have a few more plans. So we are trying out survival models for to be able to handle split changes. Split changes mean that basically because people book in days, in weeks rather than in days, that you'd have a sudden skew in your uplift. So it means you introduce more users on one side, which means on that side people will book much later, which means that then the experiment is skewed basically for weeks. So you have a huge problem doing a split change. So but with survival models we can handle at least part of that. Then then delayed conversions in general mean that we need that we're exploring methods, so we should be exploring methods that can give us an earlier read on these experiments as they're going on, rather than having to wait for months. We can maybe get an idea, a much better idea in days. And doubly robust estimation is a way to then use machine learning models again, combining survival models and the propensity weighting together to have a model that's stable against bias and has an early read with the delayed measurements. And finally the dashboard as well. So we are trying to, I'm not sure what is not coming up. Yeah, cool. So the interactive dashboard is also something important for people to play around and see different slice and dice of data, like see which segments do better, do worse, and so on. And this is something that we can still improve, and we're looking for inspiration a bit from different on different sides here. So the Growth Book, for example, is an open source product that we were looking at a little bit for inspiration at least. Yeah, that's it from me.